In this tutorial, we're going to start programming LS PLCs in a very simple way, building on what we've covered in previous lessons. We've already become familiar with the inputs and outputs of LS PLCs and how to wire them. In this lesson, we want to get more familiar with the LS PLC programming environment, which is the XG5000 software, and write a very simple program where activating one input will activate one output of the PLC. Before we get into the XG5000 software, let me mention one point. The PLC we've chosen for this tutorial is the XEC-DN32H. If you remember, in previous lessons we mentioned that this PLC model is part of the XGB series, which uses the IEC standard programming language. In this lesson we intend to write a program so that when input I04 is activated, our output Q05 will also be activated, and it will turn on a signal lamp for us. Alright, now let's enter the XG5000 software environment itself. To get started, from the project menu, we select New Project here. Alright, a new window will now open up for us. Here we will carefully write down the complete title of our current project. For example, I will personally name it Example 1 for this demonstration. For example, the next section is the file directory, where we can save the project we've defined here on our laptop or computer, any location we want. The next section is the CPU series. Since our PLC is DN32H, our CPU model will be XGB-IEC. So we select XGB-IEC. From here we make our selection. The next section is CPU type, which can have different models. Since we're talking about the Edge series, we select Edge. The next section is program name. Let me point out that in a single project, we can indeed define multiple distinct programs. We'll teach you more about this functionality a little later. Here, for example, I will name this particular program test, let's say test 1. So besides this test 1, we can also have other programs within the same project. This section is program language, which refers to the programming language. It can be ladder, SFC, ST, or IL. Here we'll start with the ladder language. In this section, you can also write a brief description about your project, like what your project is about, for example. If you come back to this file a few years later, you'll know what this project was about. Here we click OK and enter the programming environment itself. As I mentioned, we want to write a simple program where when an input is activated, an output is also activated for us. So here we need a normally open contact and a coil. We specify the normally open contact here and click on it. Now, in this programming environment, you can precisely place it on virtually any line you want, allowing for complete flexibility. For example, I bring it here and place it, then click on it. A window opens for us right here in this section. We need to specify which one of the PLC inputs this normally open contact I selected is related to. As I previously explained to you in detail, we consistently use the letter I to clearly indicate the PLC inputs, specifically for limit switches, or LS. So in this particular instance, we carefully type the letter I, and then immediately after that, here, we precisely enter the numerical value 0. This specific numerical 0 actually represents and signifies our PLC number. It is very important for me to mention and emphasize that in compact PLCs, you absolutely must enter the value 0 here without exception. However, in modular PLCs such as the advanced XGT series, this particular number can indeed be different and may vary. That is to say, if our PLC happens to be a modular PLC and we proceed to connect an additional rack to it, then the numbering scheme might change accordingly. We can enter the number of that rack here. But since our PLC here is compact, in all compact PLCs, we always set this particular value to 0. Then I type a dot, and once again I enter 0 here. This clearly indicates an option card here. However, I haven't connected any option card to my PLC, so I simply enter 0 here. If I had an option card specifically related to the LS PLC input and wanted to precisely specify it, then the situation would be different. I need to carefully enter the specific number of that particular option card right here. Again, I will type a dot. Now, since I truly want my input number 4 to be fully activated, I need to ensure everything is correct. So I will carefully enter the numerical value of 4 here and then proceed to click the OK button. As you can clearly observe, our contact is now successfully defined and prominently displayed for the input IX0.0.4. Now here I'm also going to use a coil. I will click on it and then place it in this specific section. The outputs of the PLC. We represent them with Q. Again, this is just like the inputs. Here I type in 0.0. I want output number 5 to be activated as well, so I will set this particular output to 5 and then confirm it. This action ensures that the specified output is correctly configured and ready for operation, providing the desired functionality within the system. We can see that, in fact, the output QX0.0.5 has been activated. All right, now I want to take this line of code that we've written here and import it into PLC LS. To do this, we go to the online menu and click on it. We have a connection settings option here. If we click on it, a window will open for us. Here we can specify which method we want to use to upload this program to the PLC. We can do this via RS-232. We can also do this via USB and Ethernet. Now I select USB and click OK here. Right now I have connected the PLC to my laptop using a USB cable. Now I go back to the online menu and click connect. Well, as you can see here, we are actually connected because disconnect appeared, which means we are now connected. Now if I click on right here, I can upload this simple program that I just wrote to the PLC. So I click on right here. A window opens up for us. If I click OK here, you'll see that our program is being downloaded to the PLC. We've uploaded the program to the PLC, and by pressing this push button and activating input I04, our Q05 output on the PLC will be activated. And as you can see, the signal lamp